I want you to try a little experiment with me. Just picture the last email you sent. Maybe
Yeah.
it was to your boss, maybe a quick text to a friend. You probably thought a lot about what you wanted to say, right?
Yeah.
The message, the point.
Oh, yeah, you obsess over the content? That's natural. You want to get the point across.
Exactly. But did you spend even 1 second thinking about the statistical signature you were leaving behind?
I'm going to guess no.
I'm talking about a digital fingerprint. It's hidden in the very way you put words together. Not your handwriting, but like a mathematical
Oh,
pattern.
it's the invisible layer of communication. We think we're just writing, but we're actually broadcasting a data set about ourselves.
And that is exactly what we're unpacking today. We're doing a deep dive into computational stylometry.
It's a mouthful.
It is a mouthful. Don't let the name scare you. It sounds way more complicated than the core idea.
It really is. I mean, it's just the science of using computers to analyze writing style. It's part detective work, part linguistics, and honestly, it feels a bit like a magic trick sometimes.
We are basing this whole discussion on a really comprehensive chapter by Michael P. Oakes. It's called Author Profiling, Identification, and Computational Plagiarism Detection.
Which is perfect. It basically gives us our roadmap for the day. We've got 3 big buckets to look at.
Right.
First, author identification, the classic who wrote this mystery. Then, author profiling, what kind of person wrote this? And finally, plagiarism detection.
Is this actually yours?
Or did you just steal it? Yeah.
So our mission today is to see how computers can analyze text to, solve crimes, diagnose diseases. That part completely blew my mind. And of course, catch cheaters. And they do it by looking at the words we pay the least attention to.
And that's the real irony of it. The words that give you away aren't the big fancy words you use to sound smart.
No.
It's the ones you don't even know you're typing.
So let's start with the basics. The source material brings up this concept of the human stylome. It sounds biological, doesn't it? Like the genome.
Yeah, the analogy is spot on. I think Holmes coined the term back in '97. The idea is that just as you have a unique genetic code, you have a unique stylistic code. It's a set of features in your writing that makes you you.
But surely I can change that. If I'm writing a formal report versus a text to my friend, my style is completely different.
Well, your register changes, sure. You might swap hey for dear colleague. But the stylome, it goes deeper than that. It's about the unconscious patterns.
Okay.
When you try to change your voice, you're usually focused on the content words. The nouns, the verbs, the adjectives, the stuff that carries the meaning.
Right. I'm focused on choosing excellent instead of good.
Exactly. But the computer's looking at the function words.
Okay, let's define that. What exactly is a function word?
Okay, think of language like a building. The content words, they're the bricks and the furniture. They tell you what the house looks like.
Got it.
Function words are the cement and the scaffolding. They hold the whole thing together, but you don't really look at them.
The source material actually has a great example, Taylor's list of 10 words. And it just shows how mundane these words are.
Oh, it's the most boring list you can imagine. But by 4, no, not so, the 2 and with.
The 2? Those are barely words. They're just filler.
They're high-frequency noise.
Yeah.
And that is exactly why they are so powerful for identification. Because they don't carry their own meaning. Your brain doesn't waste conscious energy selecting them. You don't pause and think, should I use of or for here?
You just do it. It's a reflex.
It's a cognitive reflex. And statistical analysis loves those because they're incredibly consistent.
And because I'm not thinking about them, I can't really fake them.
Precisely. It's a subconscious tick.
This isn't just theory, though. This focus on function words is what solved one of the biggest mysteries in American history. We have to talk about the Federalist Papers.
Ah, yes. The Super Bowl of stylometry. This is the case study that really put the whole field on the map.
Okay, so quick history refresher for anyone who needs it. It's 1787. The U.S. Constitution is being debated. A series of 85 essays get published in newspapers, all signed with the name Publius.
It was basically a big PR campaign to get the Constitution ratified.
Right.
We figured out later that it was Alexander Hamilton, John Jay, and James Madison.
Right.
But here's the problem. We knew who wrote most of them, but there are these 12 essays, the disputed papers.
And both Hamilton and Madison claim they wrote them.
Yep. And since they were both long gone by the time people really started digging in, you couldn't just ask them. For almost 2 centuries, historians were just stuck.
Because they were looking at the arguments, the politics of it.
And the ideologies were just too close. You couldn't tell them apart by what they believed.
And then the statisticians show up, Mosteller and Wallace, and they decide to just ignore the politics completely.
They didn't care about the arguments at all. They cared about the math. They use something called Bayesian analysis.
Because what did they do?
Well, without getting too deep in the weeds, they basically fed the text into a computer and just told it to count the function words.
And they found a smoking gun in, what, the prepositions?
They did. It turned out Hamilton had this statistically significant habit of using the word while.
Okay.
Madison, on the other hand, almost always used whilst.
While versus whilst. That's it. That's the tell.
It gets even better. Hamilton used on. Madison preferred upon. These are tiny, tiny differences, but when you look at thousands and thousands of words, the pattern is just undeniable.
So what was the verdict? Who wrote them?
The computer gave all 12 disputed papers to James Madison.
Wow.
And what's amazing is that much later, historical research, looking at letters and diaries, it backed up the finding. The math got it right just by counting whilsts.
I love that. Hamilton and Madison are arguing about the soul of a new nation, and a computer is just sitting there counting their prepositions.
It kind of connects to another tool the source mentions, Yule's K.
Yule's K. It sounds like a secret agent or something.
It's a measure of vocabulary richness. Basically, it looks at how often you repeat words versus introducing new ones. It gives an author a number that stays pretty stable no matter how long the text is.
And they use this to solve a debate about a religious text.
Imitazione Christi. The Imitation of Christ. Huge bestseller in the Middle Ages. And there was this massive debate over whether it was written by Thomas à Kempis or a French theologian named Gerson.
So they ran the Yule's K on it.
Yep. The text itself scored an 84.2 on the richness scale. They look at Thomas à Kempis's other works, he usually scored around 60.
Okay, so not a perfect match.
Not perfect, no. But then they looked at Gerson.
And he was...
way down at 36.
Oh, that's a huge difference.
It's a chasm. I mean, the gap between 84 and 60 is one thing, but 84 to 36, it made it highly unlikely Gerson was the author.
So it's not always about finding the right person. Sometimes it's just about ruling someone out.
Exactly. Exclusion is just as important as identification.
Okay, so that's identifying who wrote something, author identification.
Yeah.
But I want to move to the second bucket, which, I don't know, it feels a bit more invasive to me, author profiling.
Right. This is where we stop asking, who is this? And we start asking, what kind of person is this?
We're talking about figuring out gender, age, even psychological state, just from a block of text.
It's a lot.
Let's start with gender. The source cites a big study by Couple from 2003.
Yeah, this was a massive one. They used the British National Corpus. They just took a huge data set of documents where they knew the author's gender and trained an algorithm to spot the differences.
And what did the computer find? What does male writing look like versus female writing in this data set?
Well, Koppel found that male authors in the study tended to use what he called informational language.
Informational. What does that mean in practice?
It means heavy on determiners, so words like a, that. Heavy on adjectives and numbers, language that's really focused on describing objects and facts, the red car, the 50% increase.
And the female authors?
They tended to use more involved language. The data showed a higher frequency of personal pronouns, I, you, she, more verbs, more negation like not.
So, broadly speaking, one style is describing the world of things, and the other is navigating the world of people and relationships.
In that data set, that was the statistical trend, yeah. And the algorithm got it right about 80% of the time.
80%? That's wildly high for something that feels so subjective. Then there's age. The field is called stylochronometry.
Which is just a fantastic word, style time measurement.
It tracks how your writing ages with you. The example in the notes is the poet W.B. Yeats.
Right, so a researcher analyzed Yeats' poetry over his entire life, and they found you could actually date a poem just by analyzing his character sequences. They called it the Younger Yeatsian Index.
What was the tell for him? Was it about themes, writing about love when he was young and death when he was old?
See, that's what a literary critic would look for. The computer looked for the 5-character sequence, W-A-T. Or just the sequence. It could be in some odd or whatever.
Mm-hmm.
As he got older, his usage of that specific sequence it shifted consistently.
That seems so random. Why? What?
We don't always know why. That's kind of the black box of machine learning sometimes. It just spots the pattern. Maybe our sentence structures just shift as we age, and what happens to be a victim of that shift?
It's a drift in habit. But sometimes the drift isn't just habit, sometimes it's medical. This was the part of the research that really stopped me in my tracks, using writing style to diagnose diseases.
This is where the stakes get really, really high. The source talks about the Nun study, but the best example is the work on the novelist Iris Murdoch.
The British novelist. I mean, she was brilliant, won the Booker Prize, and she died of Alzheimer's.
She did. And because she was such a prolific writer, she left behind this perfect longitudinal data set, novels from her 20s, her prime, and then her final book, which was written right as the disease was taking hold, even though she hadn't been diagnosed yet.
So researchers went back and analyzed all of it.
Exactly. They compared her prime work to that final novel, and they found a clear stylistic signature of dementia long before any doctor had spotted it.
What does that look like? If I'm just reading the book, am I seeing typos? Is the plot confusing?
Not necessarily. The grammar was still perfect. Spelling was fine. That's the insidious part. On the surface, it looks fine, but the vocabulary richness had collapsed.
The Yule's K we were just talking about.
It summited. But even more specifically, she started overusing indefinite words.
Indefinite words, like thing.
Thing, something, anything, matter, one.
That makes a chilling amount of sense. If I'm looking at a coffee cup but my brain can't access the word cup, I'm going to say, pass me that thing.
It's a compensatory strategy. The brain is finding the path of least resistance. And the syntax got simpler too. The complexity of the thought was just flattening out.
It's incredible. You could get a pop-up from your word processor saying, hey, your use of indefinite nouns is up 20% this month. Maybe see a doctor.
It's a powerful idea. It suggests our language is one of the first things to show the cracks in our cognitive armor.
Okay, let's pivot to the darker side of this. We've done identity and health, but what about intent? Specifically, bad intent.
Right. This is where we get into forensic linguistics and the hunt for predators.
The notes mention personality profiling first. The big 5 traits.
Yeah, a study in 2013 showed they could predict these from social media posts. For example, high neuroticism was correlated with phrases like sick of and depressed.
Okay, well, if I'm tweeting, I'm sick of this, it doesn't take a supercomputer to guess I might be neurotic.
True, that's the low-hanging fruit. But it also picked up on things like an excessive use of I, me, mine, the kind of self-focus that correlates with anxiety.
But then you have the really heavy stuff, catching sexual predators using the perverted justice corpus.
This is a really difficult data set. It's a collection of chat logs where adults posed as minors to catch predators. And the challenge for law enforcement is that chat rooms are just chaotic.
Right. Slang, typos, noise.
It's so hard to spot the danger signal in all that noise. So researchers analyzed the logs and found these specific linguistic tells.
What are they? What's the signal?
They look for what they call approach verbs. Words like meet, see, drive.
Trying to move the interaction offline.
Exactly. But there's a much more subtle cue that I found fascinating. It's the combination of an isolation adjective and a second-person pronoun.
An isolation adjective, like lonely.
Lonely, alone, quiet. And they pair it with you. So, are you alone? Do you feel lonely?
It's grooming language.
It is. And a computer can flag that specific grammatical pattern instantly. It recognizes the script they follow. Gain access, check for isolation, then move to sexual topics. It's formulaic.
And because it's a formula, it's vulnerable to analysis. That's actually a hopeful thought.
It turns their own consistency against them.
Okay, we've done crime. We've done medicine. Now let's talk about the thing that every student listening is probably sweating about right now. Plagiarism detection.
Ah, yes, the eternal arms race.
It really is. How does the technology actually catch them? Is it just looking for matching sentences?
At a basic level, yeah. But to catch the clever ones, you have to understand fingerprinting.
Digital fingerprinting. Is that just like a C-tree RF on the entire internet?
That would be way, way too slow. Imagine taking an essay and chopping it up into tiny substrings, maybe groups of 5 words. Then you turn those substrings into unique numbers called hashes.
Okay, hashes. Explain that like I'm 5.
A hash is like a barcode. You take a sentence, run it through an algorithm, and it spits out a unique number. If you change even one letter in that sentence, the number changes completely.
So the computer isn't comparing words, it's comparing lists of barcodes.
Exactly. It compares your essay's barcodes to a massive database of barcodes from the internet. If the numbers match, the text matches.
So that catches the lazy cheater, the copy and paste.
Right, word-for-word plagiarism.
Yeah.
But then you have obfuscation.
Which is when I open Wikipedia and pull out the thesaurus.
You change the cat sat on the mat to the feline rested upon the rug. You change passive to active voice. The barcodes won't match anymore.
Or patch writing, where you stitch bits together from different sources.
Exactly. A sentence from here, a sentence from there, a Frankenstein essay.
So how do you catch that?
This is where it gets really cool. This is intrinsic plagiarism detection.
Intrinsic, meaning from within the document itself.
Yes, You don't need the source document. You just look at the essay itself for style breaks.
We're back to the stylome.
We are. Your stylum is consistent. So if I'm reading your essay, and for 3 pages your average sentence is 15 words long, and then suddenly on page 4, the sentences become 40 words long and are full of semicolons.
The red light goes off.
Exactly. The computer detects that the authorial fingerprint has mutated. It implies a second author has entered the room.
That is fascinating. It's like watching a movie where the main character suddenly starts speaking with a different accent for 5 minutes.
Perfect analogy.
Mhm.
And there's one more frontier here that's becoming a huge issue. Translation plagiarism.
Taking an article in another language, running it through a translator, and claiming it as your own.
Right. The words are all different, the hashes won't match, but the computer can detect something called translationese.
I thought that was a joke when I saw it in the notes. That's a real linguistic term.
It is. When we translate text, even if we're fluent, we tend to simplify things. We reduce vocabulary richness, we make sentences shorter, we create this weird, slightly sterile dialect that is distinct from original writing.
So a translated text just feels different to the algorithm than a text that was originally written in English?
Yes, it lacks the natural complexity, and computers are now being trained to spot that specific dialect.
It really feels like there's nowhere to hide. I mean, we went from counting whilst and upon to spotting the early onset of Alzheimer's in novels to catching predators based on how they use the word you.
If there's one big takeaway from all this, it's that language is a behavior. And like any behavior, it leaves a trace. We think we are just conveying information, but we are constantly broadcasting data about who we are.
We're broadcasting our age, our gender, our mental health, even our honesty.
And we're doing it with the words we pay the least attention to.
It's a little terrifying. You realize you are building a corpus of you every single day. Every email, every text, every message is another data point.
And that corpus is permanent.
On that cheery note, I want to leave you with one final thought from the research that really stuck with me. It's a heavy one, but it drives the point home. It's a study from Poland about suicide notes.
Right. This was to see if a computer could distinguish between a genuine suicide note and a fake one.
And could it?
It could.
Based on grammar?
Purely on syntax and lexical features. The genuine notes used more concrete nouns. They were about logistics, people, things. The fake notes used more abstract concepts and adjectives.
The fakes were trying to be dramatic.
Exactly. They were performing sadness. The people who were serious were just being factual. The grammar betrayed the intent.
That is profound, and it makes me wonder, if a computer can tell if you're faking a suicide note based on your grammar, how long until it understands your emotional state better than you do?
How long until your phone knows you're depressed before you do, just from how you typed a text message?
We might already be there. Something to think about the next time you type an email.
Indeed.
That's it for this deep dive. Thanks for listening.
See you next time.